Thank you. My name is Christian. Awesome to see you guys here. The talk is called 5 Lines of Code. And currently I go by the title founder, but really in my job and in my experience, what I have most of, I call myself a technical agile coach. And not a lot of people know what that is. So I'd like to start by just explaining it a little bit. The coach part means I like working with people. Agile comes from the Agile manifesto. And the technical part, which is actually crucial because that's what differentiates me from other Agile coaches, is the fact that I focus mostly on this one of the principles in the manifesto, saying that continuous attention to technical excellence and good design enhances agility. And that means I focus heavily on all of the technical practices like test automation, clean code, pair programming, software architecture, branching strategies, all of these things that you typically don't hear Agile coaches talk about, not in my experience at least. If I'm talking too fast, please let me know somehow. I'll try to make myself as understandable as possible and speak calmly. So also, depending on how much I race through this, we'll have more or less time for questions. We'll see. Good. Okay. So I've been a consultant for like forever, since I was done with university. And as many stories start from a former consultant, it starts with a new project. And this was the Goldmine project. This was the best one because it was an unknown technology I'd never worked with before. I'd never seen it before even. It was like a huge code base, like really scary, right? You know, and it was breaking everywhere. Like it was super fragile. You touch anything, look at it wrong, it would just break. And we had a legendary bus factor. We had one person who could deploy this software in the entire team. Nobody else could do it, right? They had no clue. And surprisingly, we did actually have a bunch of tests. Unfortunately, though, all of them were red. And the architecture we were working with was like, it looks like this, right? It was a jumbled mess. We were the third consultancy to actually get this code base. And whenever a consultancy gets a legacy code base, the first thing they do is say, this architecture is bad. We need to rewrite it completely. And then they start doing that. Well, they don't finish it quite, because then it gets expensive, right? It's very difficult to change an architecture. And so we were the third one, so it had 2 other half-done architectures somewhere in there. And yeah, it was a mess. Whenever we had to do a change, people would always be like, we don't really want to touch that part of the code. Like, can we not do this change and stuff? And so I was put on this project just as a regular developer. I had no special authority or anything, no special title. I was just a developer. But what I did have was an idea. I had this vision that I wanted to make this the project that all the other consultants wanted to be on, because then I was like, then I'll get the best people to work with me on fixing this thing. And so the team agreed to humor me, and like I was sort of an unofficial tech lead. And so I sort of tried to take that role and see what I could do with it. It couldn't get worse anyway, right? Everything was broken all the time anyway. The first thing I did was get rid of the dead weight. So that means I started by deleting most of the comments, pretty much all of them actually, and also all of the red tests. They're not giving us any confidence anyway, and it would take us more time to fix them than to just rewrite them. So get rid of all of the useless stuff. Then I also did another thing that was interesting, because the customer had this tendency that whenever a developer would demo something they built, they would always say, oh, and we also need, or could you also just, or I'm just seeing something else. And they kept having all of these disruptions all over the place. And there were so many context switches, it was impossible for anyone to get into this focus state, where like this flow state we actually want people to work in. So I said, from now on, you can't talk to the developers without me present, so that I could at least see every time they made extra requests and stuff, get an overview of how many things we'll be actually working on at once. And I also took another slightly controversial action. I took this bus factor we had and said, you can't be on the team, I'm sorry. This person had a tendency to make himself the bus factor. He wanted to be important, he liked being the only one who could do something, and that was just too dangerous for me. I needed a team that could be high functioning. And so I took this guy and I said, okay, now you tell me what to do. You don't touch a keyboard anymore, right? This is called level and strong style pairing. And it's like such an awesome concept. I just want to explain it very briefly. From head into code, an idea must go through someone else's hands, right? And so he couldn't do anything. And so I did everything, and while he was telling me what to do, I would go over in a notepad and write down what I was doing, each step, so we got it documented, or sometimes I would even record doing the steps so that I could go back and watch it and make a really good documentation afterwards. Cool. Well, with all that sort of dead weight out of our way, it was time to work on the next thing. And I was like, well, if we're super scared to change anything, probably we should work on safety. That seems to make sense. And given as how I was now the tech lead or the captain of the ship, I was like, from now on, all new code has to be tested. And I figured, now I've said it, and everything was solved. People started doing testing, and the talk is done. Not quite. In fact, nothing happened. Even worse, actually, 2 days after I had this, all new code must be tested, I had the customer ask me if they could have this feature we were working on, if that could make it into the deployment tomorrow or something. And I looked over at the developer who was working on it and said, hey, this feature, can it be done by tomorrow? And he's like, it can, if I skip testing. And I'm like, no, we just talked about this. We can't keep doing this. The code will just keep getting worse. So the problem is, we wanted to do refactoring and we wanted to do testing, right? But you can't really, these two sort of bite themselves or each other in the tail, right? You need one to have the other. So we were totally stuck. And so I figured, okay, well then maybe we should start by working with the code instead and start by refactoring it. So I would do this thing where I think every 2 weeks I would have half an hour where I would tell them a new smell. I would teach them some code smell and we'd be working on that for 2 weeks. The idea being that then the smell would be fixed and we could move on to something else, slowly improving the code base over time. But nothing happened. It stayed the same. It's apparently it's not, you can't just tell people about code smells and then they start fixing the code. The thing I noticed was that every time people were about to start refactoring something, they would sit down and start reading it, right, and trying to understand it. And because it was a poor code base, it would require them to pull in more and more details from more and more places and just build these immense mental models of what was going on. And then they lost track, and then everything was wasted in the end anyway. So yeah, and the worse the code quality, the bigger this problem gets. So this just, nothing was happening still. And at the time, I think, okay, well, maybe it's not in the code. Maybe it's actually the environment we're working in. Maybe I need to work on that instead. And at the time, I just heard about a guy called Woody Sewell who had this amazing saying, the object is not to create great software, but to create an environment where the great software is inevitable. And I was like, yes, this sounds like the solution. Surely this must be it. And so I introduced a concept called Improvement Mondays, where we just tell developers, you can work on whatever you want. It's completely unstructured. Just do something, right? Usually they want to work on the thing that annoyed them last week. And the way we've structured these Improvement Mondays, I've actually done them many times since because I find it's a great way to start actually moving a team towards something better. And we would start with 10 minutes of pitch and recruit, where everybody would say something that they wanted to work on. It could be like refactoring the code or like documenting some process, learning something new, whatever, right? Everybody says something. And then afterwards, the recruit part, where people will be like, oh, I need actually someone to help me with this thing. So people say, I want to work with that on you, or can we do this thing, can we go? So nobody works alone, right? It's also a team activity. Then we spent 10 minutes just defining a more specific goal, because refactor the code is too vague, right? You have to be like, what can you actually do today and get through? So refactor this class, that would be good. Write this section about this thing, that's better. And then we have this big block of focus time where we use something called Ensamble programming, where we have one big screen, usually it's a big screen, but it could just be one screen, one keyboard. Then we have a driver, who's the person actually typing on the keyboard. And this is another instance of strong style pairing I talked about earlier. So we also have a navigator, who's really the programmer, the brain behind everything, and they dictate everything that goes on. And then the driver types it in. It only types in what the navigator says. And everybody else is part of the ensemble. These are people that can be accessed whenever somebody gets stuck or doesn't know what to do, something like that. And so you have this amazing way to have all of the competences you need working on the same thing together, right? And then we take turns switching every 3 to 6 minutes, something like that. And so we do that for our focus time. Then we get to lunch, and when we come back, we touch base again. We're like, okay, now we can say, are we still working on this thing? Do we still have the competences we need? Should we swap people around, something like that? Also, it's like, I've never understood why people place something like the Scrum meetings in the top of the day usually, because people show up at different times, and it's like, no, not everybody is on the same page. Somebody's been working for 2 hours, somebody's just woken up at that point. It's like, that's not a great time to sync, in my opinion. It should be like right after lunch is usually when everybody is just done the same thing, right? And everybody is in the same frame of mind. It also eliminates another context switch. Cool. Then we do another focus time, and we end the day with a mini review, where we just say, yeah, we did the thing that we said we were going to do. In the beginning, that's not going to happen, but over time, people sort of get used to the size of tickets they can work on. And we also do a mini review, and I really like doing the loved, learned, lacked method. And these are things that come up every single time I've done Improvement Monday like this. It's like, it's great working together. Somebody learned to use their tools better, which is immediately valuable. And there are too many disruptions. It's really hard to block out an entire day for unstructured work. But it's so important. And now, having given them the optimal environment, surely the code base was fixed, right? No. Still nothing happened. This puzzled me. This was really weird to me, because I figured now we must have fixed everything. Like, where can we go from here even? But it turns out that like you can't just do something in like a toy example, sort of trying to learn something on an Improvement Monday and then go and put it into your production code. That feels extremely scary. And so the lack of practice was really holding us back in this case. And so I figured, well, maybe it's the smells that are broken, right? Maybe it's the code smells. So I would go back and I would look at a lot of books with a lot of different code smells and try to figure out, could I make these more approachable or more applicable, something like that, right? Could I change something about this that would make the code base actually start to move? And so I had 3 requirements for the rules that I wanted to create. The first one is they had to be easy to remember, because if I'm just adding more stuff people need to remember, I'm doing the exact same thing that the smells are doing, which didn't work. They have to be easy to remember. They have to be syntactic. So that means you should be able to look at the code and know instinctively whether it was following a rule or not, like whether it was illegal, right? Again, I can't add more cognitive load to the people. They were already working hard on the things they were building. And the third thing is they had to be safe, even without testing. Right? And without understanding the code, without all of the safeguards that we normally have. I wanted to come up with something where it's like, well, you can't destroy the code with these. That means I also had to come up with new refactoring patterns, new tools, right? Because all of the established refactoring thing rely heavily on testing, right? It's like, you should have high test coverage and then run your test 3 times during the refactoring. But we didn't have that. We had 0 test coverage that worked. So I sat down and I thought, what are some low-risk operations that I can rely on people to do safely? The first one I came up with was copying and pasting. First of all, most people will practice in that already, which is great. But also, it's really difficult to destroy something by copying it and pasting it. You have to be very nefarious to destroy something like that. So it's mostly safe. Also, if people take very small steps, they tend not to fuck things up, right? It's harder to fuck things up if you do things in a very small steps. As it turns out, this was the the most risky thing I introduced into the team, was relying on small steps. Because once people have done it 2 or 3 times, they can't slow down. They want to go really fast, right? And they skip 15 steps and everything starts going wrong. But I figured at the time that if I could make people take small steps, it would be safe. And I still think that. It's just very hard to make people slow down. The third part, or the component, was the compiler. We have all this tooling that's already working, right? We were working in, I think it was C# at the time, but it was a typed language. So we have a compiler, really strong tool, and it will check the code, right, in detail if we don't try to misuse it. And things actually started to improve. Like, things started to move all of a sudden. It was like getting unstuck, and it was just, whoa, what is this amazing thing? And so now I'd like to show you sort of a little piece of code and how it would move through with some of these rules and refactorings I came up with, to give you a sense of what I'm talking about. Cool. So the journey from smells to rules. In the if we start with the classical work, right, Martin Fowler's refactoring book, it has a smell like don't have long methods, which is great advice. It's just not very applicable, not easily applicable at least, because is it 30 lines? Is it 300 lines? Is it 2? When is the method too long? And so I sat down and I was like, okay, let's just say 5 lines. That's it. You can have 5 lines per method, and that's fine. My intention for doing this was that it would force a lot of if statements to be dealt with, right? Everything else is pretty easy. You could just split it up wherever there are sections in the code. But if-else chaining is really difficult to do this with if you don't have the tools to fix it. So it sort of forced people to learn better tools. Also, I count lines in the intuitive way that you expect. Like, this is 5 lines. I don't count the braces and the blank lines and stuff like that. So it's like lines that have something on them. That's interesting. Good. So let's look at an example. The only thing you have to know is that in Denmark, the traffic lights have 4 states because they can be yellow, red, where it's like you can't quite drive, but you can almost drive. Right? It's about to get ready to drive. So yeah, and then we have some update car. The first thing we notice is that we have this switch there, and switches are evil. These are actually probably the easiest smell to take directly from Martin Fowler, because he also says switches are evil. So let's get rid of that one, replace it with if-else chaining. Okay, cool. So we're still doing the same thing, yeah, good. I think that's good. Now we want to replace this enum thing that the switches were actually tied to, because the enum, as it turns out, also is a rule. In fact, the rule here is you can't have an if with an else on it, which is a much harder rule. And we have plenty of that right here. So we need to replace the enum, and the way to do that in a safe way is we start by renaming the enum actually to something else, because now the compiler will find all of the places where we're using this enum, right? Regarding, we don't use reflection or something like nasty like that. Right? If we're not trying to cheat the compiler, it will actually help us find all of these references. And so now we'll know everywhere we need to go to fix something, and then we'll also know when we're done, because when the compiler is green, we're done with the refactoring, which is great. So we've renamed the enum. Now it's time to create a bunch of classes. We create actually an interface with a method for each of the values in the original enum, and we also create a class implementing that interface with the same 4 methods, right? But with one of them being true, the appropriate one, in this case, yellow. So we now have like 4 classes with 4 methods. And this can get, if you have an enum with like 60 values, this means a lot of classes and a lot of typing. So hopefully some of you are getting paid by the line. You'll get rich by this. Cool. That also means that when we're done with that, we can actually replace these equals that we have in the original code with calls to these new methods, is green and is yellow, red. That will do the same thing. And that means we've gotten rid of the enum entirely. If we look at the code now, we still have the if-else, right? So we're not done with the rule yet. We still have an else. So now it's time to actually push this code into class. And the way we do that is by copying it straight from where it is into the method, straight into all of these. And we remove, of course, the function, because now it's a method, small details like that. We also give it a wrong name in the interface, right? And that's, again, because we rely on the compiler to tell us, are we done with this refactoring yet or not? And we're not quite done, so we want it to give us errors everywhere in all of the classes, because they're not quite finished. We also replace, because over here it was the lights we were calling on, and now it's pushed into the lights, so we replace light with this and remove the parameter. Again, that's also, the compiler helps us with that, all that stuff. Cool. So now we have this thing that doesn't compile, and it's because the next step is actually to go and simplify some of this. Specifically, we know what is green and is yellow, red are going to return, right? We know the values that are just above, so we can just inline them directly. And again, this is fairly easy to simplify, because we can just remove all of the false branches of the if. Right? And we were left with this thing. And the if just disappears. The first time I saw this, I was like, this is amazing. We went from some code that has an if, and once we've done this in all of the 4 classes, there is no if in the code anymore. It's just gone. It's not there, which is just, yeah, mind-blowing to me. We also, at this point, are done with this class, so we rename the method to the appropriate name, and we no longer get an error, right? So we can see how far are we from being done with these transformations. Cool. Yeah, and then we have. Do we also do like a small renaming, I think, because now we're done with all of the methods in all of the classes, let's say. We also need to, of course, rename it back to the permanent name. So we just remove the temp on the end there. Yeah, good. After we've done this, and all the if, or the if has gone entirely away, we're actually not using these methods anymore in any of the code, so we can get rid of them again. These turns out also to be a smell in the long run. If you keep all of your is methods, it's because you're not done weeding out all of the if statements. So these all go away too, right? So even though we added in a bunch of stuff, we're also removing a bunch of stuff. Breeding this other thing that I really love to get people as excited about, deleting things. Right? It's so much cooler than adding things. It's because you have less stuff to carry around, right? So I really wanted people to just add stuff all the time and delete it also all the time, so we can get like a flexible code base. Cool. Okay. Let's say that after some time we decide that these two actually we add some methods to actually control the lights. These are not the same is methods as we have before. These are like methods for the traffic light control thing. Let's say it's just an imaginary example, right? And let's say we have these two yellow classes, but we actually have decided it makes sense to unify these. It makes sense they should change together, so probably they shouldn't be two different classes. And so I'll just like to show you another technique that we use, is really what I'm trying to say. The way we do this is fairly interesting. The first thing is we pick a basis method, like a method that will uniquely identify which of these two cases we're in. In this case, only the is red light on is different. Everything else is pretty much the same. Also update car, but it needs to be a constant method. And so then we add if statements to the body here that are expressed in terms of the basis method. So in this case, the red light on, and not red light on down there. We're doing the opposite thing of the simplification we did earlier. So we're just adding this. This is still doing exactly the same thing. It's just a little more convoluted. Then the next thing we do is we actually take the body from one of them and paste it in the other one, and then do the opposite as well. So this body from the yellow-red comes into the yellow, and the opposite one goes in the opposite one. I've also added an else because they can't possibly be true at the same time, right? Only one of them will be true. That's sort of the point of them being a basis method. Here, of course, because we have something that's a Boolean, we can simplify it a little bit and just remove the if not part. That doesn't matter. It's a Boolean, it has two values. And now, we actually have, the next thing we need to do is generalize this field that we used for our basis method. And we do that by adding a constructor, which looks a little bit weird in TypeScript, but it's, that's just a private field that's being initialized from a constructor. And then we use that method instead of calling the other method we had before, instead of having it be constant. And that means now that if we compare yellow and yellow-red, they will be textually equal except for the title. And if you're using something like Java, also the constructor name, right? But everything else is character for character equal, which is nice because then we can just remove one of them, right? We already have all the functionality. We can just call the other one. And again, when we remove one of them, the compiler will tell us everywhere we need to go and fix it, right? Which will be just removing the red part. We can just keep our favorite. Okay, cool. And if we look at the code now, we actually have a new if with an else, right? And we can go back and repeat all of the same steps to get a new, a Boolean is actually just an enum, so we do the same thing, we replace it with classes and all this stuff. And it turns out there are these flows that we kept working in when we were doing refactoring. We started by extracting a method because we wanted to isolate the switch. Then we do like the switch to the if-else. Then we do, if we have some equals, we would replace that with type codes and classes. And then we had the is methods that we push the code into the classes. And the if is gone. And we can inline the original code because it's now just a single line. So it might not make sense to extract it anymore. And these flows are like, they appeared out of sort of a emergent behavior from all of the rules that I happened to come up with. Cool. I'd like to also explain why this is important, why this actually had any effect at all. And the thing is, first I need to define two things, actually. The first being invariance. And the way I like to tell people about it is it's something that the developer knows, but the compiler doesn't know, right? It's everything we need to keep in our heads while we're coding, not to mess up. Right? So it could be something like array length can't be negative, or it can be like you can't have negative number of items in a cart online or something like that. And some of them are safe, like array length is pretty safe. Some of them are not so safe and tend to change over time, and we forget them, and that's when bugs start to happen. Another reason bugs start to happen, or something that makes them worse at least, is coupling. And the way that I define it is when we have code that's shared between multiple teams. And I'm using team here as being in the same state of flow. So if your team works as a bunch of individuals, each with their own tickets, you are separate teams in my book, right? So this, you can have coupling also inside a team. But if everybody works on the same thing, you have one state of flow, and you don't get this coupling problem as much. It's very common in utility classes, data classes, all of these dumb classes or something. And that just means we can't change them now because so many people are relying on them, right? And if I change it over here, it might affect something somewhere else that I don't want it to affect. I have an example that actually exhibits both of these things in excess. And it's a very brief example. But what's interesting is we can actually say something about, we can say a bunch of stuff about this code. First of all, like the type of ARR, we can probably give a reasonable guess because that looks sort of like it's a numerical array, right? It has numbers in it. It has the indexing. We also have an invariant, and I even talked about it before, that array length is well behaved. In this case, again, it's probably safe. If it's the built-in length, at least, it tends to behave well. But there's this great book called Java Puzzlers, where it has a section in the middle to just come up with weird ways to mess up loops that look normal and make them into infinite loops. And it's such a fun exercise because it's like, these look like things that can never be false, right? Equals x equals x. That must be true always, right? No. Not always, not if it's nan or something like that, right? It's super weird. So here we have an invariant that length is well behaved. We also have another invariant actually, that this one doesn't cause an overflow. We're not handling it, so that must mean we think it can't happen, right? So that's an invariant we need to keep in mind for the numbers in this thing. We also have a different coupling actually, and this is more of like a fun one because I'm a programming languages guy. But we have this uppercase L for length. And I know pretty much only one language that does that, and so this is probably C#. I think there are others, but this is probably C#. Also, I wrote it, so I know it's C#. But the thing is, it's super interesting. We can say something about things that are not displayed here, right? There's coupling there. Contrast that with another way of writing the same piece of code would be r.map x plus 2. So this, of course, it still has the overflow invariant, because we didn't change anything in that. And it also still has the C# thing. But we can't say what the type of this variable is anymore. It could be any collection, so long as it is mappable, or whatever that's called in the different languages. So we've reduced the coupling, right? And we have fewer invariants also, because we don't rely on array length anymore. And when we take this to the scale of like a whole code base, we'll have something like our enum for the different light states that we had. The invariants that are tied to that will be pushed out into all of these different places, right? Where we're controlling it, the light, for the car behavior and for the pedestrians. All these different things will now need to know about the order of the lights and all these other things that we attributed on top of what's already there. Whereas when we change that for classes, we do the opposite operation, right? We are pulling all the invariants into the classes where the behavior is shared. So everything that has to do with the yellow lights is now in one file, and you can see it, and it's much easier to get like a handle on. Right? So the invariants are localized, I like to say, and that's pretty much the biggest effect refactoring can have if you have really bad code quality. The first thing you should work on is the invariants, because that's what makes it unsafe. That's what makes it slow to work with, and that's what makes it such a dread, because we feel like we're unproductive, right? If we can't run, then it's not fun to do coding. Yeah. So, and just to wrap up, the story from the beginning, we did actually get to be the team that everybody wanted to be on. We had like the favorite team. We ran out of money 2 months later, so it was a short-lived process. But it was, we were very happy while it was going on. And so, if I had to do it again, here's the order in which I would do all of these things, because I don't think any of them were wrong in itself. I think it was the collection of things that really turned out to give the greatest benefit. And I think the first thing you need to do is create technical vision in the team, actually on all levels of an organization. I think it's horrible when we have these people managing other people doing software that don't know how to build software. It's like, how can we speak the same language? And I heard this great quote recently that I'm totally going to steal next time I'm doing like a transformation like this. And it is, you can either teach the developers project management or you can learn coding. But you have to learn the same language somehow, right? You can't communicate if we don't know what we're doing. So we need something like a tech lead. And again, I don't mean by title or by official. You could just have that role, that responsibility somehow. Second thing, environment for excellence. Very easy to get started with. Doing more pair programming, doing more ensemble programming, and having unstructured time, preferably like a large chunk. All of the different models I can talk of at length, like extra 20% on each ticket, or 20 what's it called, the improvement sprint and stuff. Don't like them. Only Improvement Monday has given me consistent good results in practice when doing these things. The next step would be to remove waste, right? Get rid of everything you can. Delete stuff, comments, interruptions, bus factors, all this stuff that makes it, again, that prevents the team from running fast. You just get out of the code base immediately. And then prioritize safety higher. And there are so many things we know causes better safety. It could be smaller batches, using the tools we have. This is especially something I'm passionate about, because it seems like, oh, we'll just add testing. But then you are adding another tool to a team that isn't using the tools they have. How do you think that's going to go? Why would that change anything, right? Just use whatever tools you have and then define like a quality strategy. How are we working safely in this team? And then localizing and variance, like, such an important step. And finally, reduce cognitive overhead. We're already, whenever we sit down with some work to do, some task to be solved, we fill up our whole cognitive capacity with that thing we're trying to solve, right? We get enveloped by the thing. And that means you can't add all these other things in. They're just going to be pushed out whenever we start working and whenever we get back to work. Only the habits are what will remain. So for me, it was like, have simpler rules and simpler code, right? Also fewer tools and stuff like that could be on this list. I think we have some time, actually, so I hope we asked a bunch of questions. Otherwise, I just want to say thank you very much for listening.